Okay, we are looking at the review for the transformation test. Please make sure you have the correct answers for this. Okay, what kind of transformation is this, first of all? Number one. It is a translation. And what's the rule? What would I do to x?
Plus 4.
I would add 4 to it. And what would I do to y?
Minus 9.
Yep. If I did that for a, b, and c, I would get a naught, b naught, c naught. Okay. Ready for the next one? Questions, comments, concerns? All right, number 2. We're reflecting it across the dotted line. So I know it's kind of hard to see on here, but basically it's just whatever on one side, you have to put it on the other. So this is 1 away. This is 3 away. 1, 2, 3. So I've got C. Can you guys see it? I know it's dark.
Yeah.
The A is 2 away, so it's 2 away on the other side. And then you connect. Okay. These first 8 questions that are on here, I believe it's the first 8, but we'll make sure, are going to be multiple choice. So this one will give you either those points, or it'll give you 4 different pictures to choose from. This one, it'll give you different things, 4 different things to choose from. Levon, can you take your hat off for me too? Okay. Number 3, when the point -2 is reflected over the y-axis, what is the new point going to be? Whenever we go over the y-axis, what changes, the x or the y? X. So it changes to 2, 4. That's it. Again, this will make more sense because it'll be pictures with multiple choice. 4. All right. So this was a boo-boo on my part. I was changing this from a multiple choice question to a regular question and forgot to draw in the triangle. You can draw in any triangle you want. If you want to draw the same one I have, that's fine. If you have a different one, that's fine too. Okay, so I'm going to say this is A, B, and C. The first thing I'm going to do is bring everything down 2. So that's 1, 2. Here's my new A. B is 1, 2. C is 1, 2. Okay, so that's the first thing. Those are my first image. My second image is to reflect over the x-axis. So this is my final answer. And this is 1, 2, 3, 4. Does that make sense? Anybody confused? Want me to go over something in more detail?
It says reflection of y equals 0. Is that
Yep. Yep, and I'll leave it up on the board right there, where it says y equals 0, x-axis, and stuff like that. All right. Drawing vectors. This one will actually, when you see it on the quiz, it'll say here is the vector, which one matches it. But a vector is just from one vertices to the other. Okay, so this one went over 3, up 3. This one went up none, over 3. This one went, over and then up. And this one only went up. Okay, the vector will just look like that. You'll just have to count and figure out which one wants to be what. So it'll look like this. You'll have a little vector. It'll be drawn like this. And it'll be like, okay, you'll be like, this means over 2, up 2. So you'll figure out which triangle is over 2, up 2. Does that make sense?
Yeah.
Okay, I just want you to be clear for the text. Okay. What kind of rotation is number 6? Is it 180, 90, 270, 360? It is 90 degrees.
90 degrees
Clockwise. Good. Okay. What happened here? We went from start to here to finish. So it looks like we did 2 reflections. What do those 2 reflections add up to if I wanted to just go from start to finish and skip the middle? It would be a what? Rotation of how much?
180.
Because we know when two lines intersect, if you reflect over both of them, it is a rotation. See how these meet at a 90-degree angle? Therefore, we have to know that it's going to be a rotation of 180 degrees. Okay, let's turn it over. All right, who remembers the formula? If I have two lines, it's the second line minus the first line times 2 is going to be our total distance, and we want to move 8 to the right. So 8 equals 2 times, we don't know what the second line is, so I'm just going to write x, minus 3. So I divide both sides by 2. I add 3. So my answer is 7. So I know I'm going to reflect over x equals 3, and then I'm going to reflect over x equals 3, 4, 5, 6, 7. That's it. That's all it wants. I know it says write the composite there, but I'm not going to make you do that on the quiz, so don't worry about it. That's us. What? It would be like x plus 8 comma y. All right. Are we ready for 10? Or you need another 10? Okay. The answer for number 9 is 7. Okay. The graph is there to help you, but you don't have to do anything with it. If you just use that equation, you'll be fine. But you do need to know that the second minus the first times 2 is how you know how much it moves over. Okay. Number 10. All right, what do I do when I reflect over x equals 0? I look up there on the board, and I know it's negative x comma y. When I reflect over y equals 0, I know it's x negative y. Okay, so first I'm going to change these to negative x comma y. So I'm going to get negative 3, negative 2, negative 1, negative 6, negative 6, negative 10. Now I'm going to take these answers and I'm going to change it to x negative y. The biggest mistake I've been seeing on these is people are going back to the beginning to change it. Remember, you change it, the originals to go to A naught, and to go from A naught to A naught naught, you have to change the ones you just did. So I'm going to keep x the same, but I'm going to change the signs of all of my y's. Okay? So what is the composite? How do I get from the top to the bottom? So did my x change? What happened to my x value? It changed to what? Negative. What happened to my y value? What's a negative times a negative? Positive. So I times it by a negative, right? Okay, what kind of rotation is that? 180 degrees. Perfect. Again, this graph is right here. Some of you are going to be like, I don't understand how you could tell that was 180 degrees. You get confused looking up there, looking for the rotation. But maybe if you graphed the top, the first one's graphed for you, if you graphed the bottom one, maybe you'd see that it was 180 degrees. So that's why the graph is there. Any other questions about this? Okay, let's move to 11. All right, the first thing you want to know is that we're going to move A, and point A was supposed to show up in this box. I don't know why it didn't. Computers and I don't always get along. All right, so here's my parallel line, my perpendicular line to my two parallel lines. I'm going to make the distance between line 1 and A x. I'm going to make the distance between A and line 2 y. Okay, so first I'm going to reflect it over line 1. So here's A naught, and how much is the distance away? If it's x on this side, it's got to be x on that side. Okay, now I've got to take the whole thing and reflect it over line 2, A naught naught. How much is that away? How much do I have on this side?
2x.
Yep. Okay, so line 1 to line 2 is how much? What is A to A naught naught? 2x plus 2y. Good? You guys, that was the best quiz you guys did on, so I hope you got that one. All right, ready for the next one? Tell me to slow down if I go too fast. The point is that you get it, not that I finish it quickly. All right, let's move on to 12, unless there are any complaints. We will stop, nothing. All right, our next proof one. What do I do first? A to the point of intersection. Yep. Okay, let's make the distance from my A point to line 1 x degrees. Okay, now I'm going to reflect over line 1, right? So I've got A, and I can make a perpendicular line to here so I can see exactly where it goes. What is the distance between line 1 and A naught naught? A naught, excuse me, x. Good. Because we reflected over. Now what's the difference between A naught and line 2? Y. Okay? And now I've got to reflect A naught over line 2 to get A naught naught. And what's that degrees away?
X.
It's y. Okay, so line 1 to line 2 is how much away? X plus y. And A to A naught naught is how much away? 2x plus 2y. Yeah. Next. All right, the next 3 problems are what we learned from this week. What we did Monday, Tuesday, Wednesday, so please make sure you ask. Okay, if you have any questions. What do I do first, though? Draw from the vertices to A. And it's going positive direction, right? All right. Now what do I do? Okay, so I'm going to measure the point from A to B. That's 1. Now I've got to figure out what half that size is because I need 1 1/2. So A to C, I go half of it, I need half more. A to D, there's 1, I need half of A to D. That's a half more. Okay, so that's 1 1/2 away from A. So now I connect them. And I've got D naught, C naught, B naught. Questions about the dilation? Yes. So I go from A to B, right? And it says 1 1/2. So I know my new A has to be 1 1/2 more away. So I look on my compass. I'm like, okay, this is 1. So I get like 4. So I put my compass on 2, and then I measure 2 from there. Does that make sense? So it's always how far it is from A. So that's 1 1/2, 1 1/2, 1 1/2. Okay, so always put it on A. If it was negative, where would it be instead? On the bottom. Yeah. Yes. All right, next. Okay. What is this? Is this a translation, rotation, dilation, or reflection? Okay, it's rotation. Okay. This is where I would get myself some patty paper if I were you, because I do feel still that that is the best way to do this. I would trace and try to figure out where my center is. You could even do it the opposite way. If I go from here. Nope. That's better. So it's approximately here is my center. And then you know this is B naught right here. We trace, we connect them to the center, and then I'm going to measure it. I'm going to say this is approximately 50 degrees. Okay. Now, if it was a reflection, you would have to draw the dotted line. If it's a dilation, you'd have to find the center of the dilation, and that would be connecting the vertices, and then you could find the center and then tell me the magnitude. If it was a translation, you're just telling me the vector. Yes? How do you know it's 50 degrees? I measured like this. I put the center, right, see where my,
Are we gonna have it?
yeah, you'll have these. You'll have patty paper and protractors and compasses all at your table. I don't expect you to guess and just know off the top of your head. All right, last problem. What two transformations must take place to get from here to here? Dilation is the first one. What's the second one?
Reflection.
You think I reflected it. Don't dilations reflect already?
No.
Let's go back.
Wait, it's negative.
If it was a negative, it would reflect already, right?
Right.
Right? So I think it's a dilation and a translation. This problem will be extra credit on your test.
Oh, it's good, but how do you do it?
Okay, so the first thing I know it's a dilation, but look how these don't really match up, right? I know it would have to be a negative dilation, but see when I put them here, they're supposed to intersect, right, when you do a dilation, so you can find the center of dilation, so something else had to take place. You guys might have been right, I might be wrong. I am wrong. It's a dilation of about a half, and it is a reflection. You guys are right. But it will be extra credit. So if this one is, you're like, I still don't get how you see that or do that, don't worry about it. It is extra credit. Any other questions? We have a lot of time in class left. I do expect you guys to be getting a piece of paper and putting it on top of each of these problems and see if you can figure it out without it. Okay? You could also get out any of the worksheets we did based on these and try them again if you want more practice, because like I promise you right now, this problem right here, this exact problem, will not be on your test. It'll be one similar to this. It'll probably be one directly from this packet, but it won't be this one. Does that make sense? Like I wouldn't give you the exact same thing. It's 100 points. I'll test it 100. Any other questions? If you did not finish any of the packets from this week, or there's one that you didn't finish, I strongly suggest you start with that one.
Practice has like 1 quiz right now.